On example 8, we want to find the derivative with respect to x of f of x plus g of x. This is a sum of two functions. So if we're adding two functions and we're taking the derivative, what do you guess? Just try to take a guess. Anticipate what you think the derivative is going to be, and let's see if we can figure out if that's actually true using the limit definition. Okay, so I don't anticipate this is enough room, so I'm going to add an extra page. All right, and think about this. In order to apply that limit definition, let's rename this here just to make it easier to apply. I'm going to call the function f of x plus g of x, let's call it s of x. It's a sum, right? Okay, that makes sense. S of x is equal to f of x plus g of x. And now I'm going to find s prime of x by applying the limit definition to this. So limit as h goes to 0, it's going to be s of x plus h minus s of x, all of this over h. So I did that so it's going to be a little bit easier for us to wrap our head around plugging x plus h into both of these little pieces. So let's continue, shall we? So this is the limit as h goes to 0 of, I plug in x plus h into both of these x's, and I get f of x plus h plus g of x plus h. And now I need to subtract out our s of x function. So I need to put this probably in some brackets or parentheses or something like this. F of x plus g of x. Alternatively, you could just remember to distribute your negative sign, which is what I'm about to do, over h. All right, distribute the negative sign. Yep. Done. Okay. And now nothing cancels. Oh, I wonder if we could just kind of rearrange things. Like, for example, this. No, try that again. This term here, this has got f's in it, and this has f's in it. This has g's in it, and this has g's in it. What if we were to just like rearrange it like this? This is all addition and subtraction. Doesn't really matter what order we go in as long as we keep the signs correct. So limit as h goes to 0, f of x plus h minus f of x, like that, right? And then I'm going to pair up, let's say, the g's together like so. And then I'm also going to obnoxiously zoom in for no apparent reason, plus g of x plus h minus g of x, all of this over h. All right, now it's coming together. Now what I'm going to do is I'm going to treat this separately from this. I'm going to rewrite this as two separate functions, okay? Is equal to the limit as h goes to 0. Maybe you can see where this is going. F of x plus h minus f of x. I'm going to make that over h as two separate fractions again. G of x plus h minus g of x, all of that over h. And I did that because now I can very clearly see that this right here is the limit definition of f of x, and this is the limit definition of g of x. So this is equal to f prime of x plus g prime of x. In other words, the derivative of a sum of two functions is the sum of the two derivatives, just like you probably anticipated. So let's come over here and write something up. It also works for subtraction, addition and subtraction. Sum or difference rule. Sum or difference of two differentiable functions, f and g. Differentiable, what does that mean? That means you can take the derivative. So the sum and difference of these two functions is itself differentiable. Moreover, the derivative of f plus g or f minus g is the sum or difference of the derivatives of f and g. You don't have to write all that. You could just write this, right? Here's the sum rule. The derivative with respect to x of f of x plus g of x is f prime of x plus g prime of x. And it also works for subtraction. The derivative with respect to x of f of x minus g of x is equal to f prime of x minus g prime of x. I wonder if it works for products and quotients. That's a good question. In the meantime, next video we'll apply the sum and difference rules.